Okay, let's start Part B of Section 2.1 of Business Eco 1. We left off with two examples that had unique solutions. One solution that satisfied both of the linear equations. And now let's see what else we can do with these examples. We notice on this example here that they're all positive. They are 4x plus 3y equals 9, 8x plus 6y equals 4. So our first step would be to find the LCM and multiply by the opposite number. So we're going to take line 1 and multiply by a -2. So do a -2 times the 4x plus the 3y equals 9. Then we'll bring down the second linear equation in order to finalize what we need done. So if I distribute a -2, I get a -8x, a -6y equal to a -18. Now I didn't do anything to the second linear equation, so I'm just going to write it. 8x plus 6y equals 4. When I add vertically, I get 0 and 0 for both variables. So 0 on the left side is equal to a -14. Well, this is false. That can't happen. It is false. Therefore, there is no solution. So, this system of equations is inconsistent. There is no solution. No solution whatsoever. All right. Well, let's look at this next one. Yes, it's got fractions, but don't worry. We're going to multiply each equation by its LCM. It's common multiple. Well, in order to get rid of a denominator, you just multiply by it. So we're going to multiply line 1 by 3 to remove all of the denominators. And we're going to multiply by 7 for the second linear equation. When we do that, I'm going to get x plus the 3y's, again, we're multiplying through the entire thing, equal to a -10. On the second line, we're going to get an x plus 7y equals to a -38. All right. Well, now we're going to multiply either the first or the second. It doesn't matter. We're going to multiply a -1 through the first one. And we're going to keep the second one as it is so that the x's will zero out. When I do that, I'm going to have a -x, a -3y, and a +10. And to it, I'm going to do the second linear equation. I'm going to add vertically. This zeroes out, so I'm left with 4y because -3y plus 7y is equal to 4y's is equal to a -28. I'm sorry. Bad math. Now I'm going to divide by 4 so that y is a -7. 7 times 4 is 28. Well, now that I've done that, I'm now going to find the value of x. All right, since I have a -7, and it is for x, I am going to use the second equation. X over 7 plus y, or the first, it wouldn't have mattered, would it? No, it wouldn't. I'm going to use the second one. Y equals negative 38/7. So I'm going to do that. I'm going to insert my negative 7. All right. And now I'm going to add it. I'm going to add 7 to both sides. When I do that, I'm going to have a negative 38/7 plus, and that would make it 49/7. Okay, 7 over 7 times 7 over 1 is 49/7 over that. So I'm going to end up with, it looks like 11, right? Oh, yes, right. Let's see. Let me see if I got this right. 7, and I got negative 7. Negative 7. I'm going to add 7. 49. All right, it sure looks it, doesn't it? Okay, so this is going to give me, so 49, and my brain is dead. Sorry about that. My brain is dead, so I'm going to write it. Negative 38. Well, I'm just going to say, let me clear that. Negative 38 plus the 49. And I get 11. And it's positive. So I have x over 7 equal to 11/7. I'm going to multiply by 7, and those cancel, so x is 11. All right, so now that I have that, then I have the ordered pair of negative 7 and 11. Oh, sorry, I have it in reverse. X is always first, and this is my solution set. Well, we're going to check it. Now, because this is a fraction, we're going to do it by calculator. So here we go, so that nobody gets nervous or thinks he can't do it. All right, so I'm going to insert 11 for 7. Hold that thought. Where's my calculator go? There it is. All right. Okay. So I'm going to say 11 divided by 3 plus negative 7 and enter. I get that. Now I'm going to do negative 10 divided by 3, and it checks. Good. Now we're going to do the next one. Now remember, x is still 11, right? 11 divided by 7 plus negative 7, enter, and I get that number. And now I'm going to do the 10, negative 38 divided by 7, and I get the same answer. So we checked by calculator. And it is a good solution. So 11 over negative 7 is a unique solution for the system of equation. And that was an example of a fraction. Right. So we have this one here. Let's look at this one. So we have 3 variables, and we already have one that zeroes out. So how would we do this, right? Well, the first part is easy. We're going to just add them, and we're going to zero them out. And then from that point, we're going to find an identity. So let's see what we have. So I'm going to have the 2x plus 5y minus z equals 2. And then I'm going to have the 3x plus 8y plus z equals 5. I'm going to add vertically. This is 5x plus 13y. This zeroes out, equals 7. Okay, now what am I going to do with that? All right. Well, now that I have that, I am going to solve. Um, do with that. Now, well, I'm going to have an identity, but it's an ugly identity. So this is ugly. So let's go another route. Let's go ahead and get rid of something else. What did we get rid of? How about the x's? So this didn't work. So plan 2. Sometimes it doesn't work because this is too ugly to work with. So we're going to try another thing. So I'm going to multiply 3 times the 2x plus 5y minus z equals 2. And I'm going to multiply by a negative 2 to the 3x plus 8y plus z equals 5. That's what I'm going to do. All right, let's see what I get this time. And maybe it's more workable. This made another fraction occur, and I don't want fractions. I want to just do the math. So this is going to be 15y minus 3z equal 6. And on the bottom, I'm going to have a negative 6x minus 16y minus 2z equal negative 10, I believe. Let's see. Negative 6, negative 16, 8 and 8, and those were all positive, and a negative 10. Okay. All right. So let's see what we have now. This zeroes out. So I have a negative y plus a z equals negative 4. Do you agree? All righty then. Because we have a z, we want everything in terms of z. And that's what I forgot. And that's why I'm messed up. So we're going to solve for y. Negative y equals negative z minus 4. I'm going to divide by negative 1. Y is z plus 4. Okay, this one has many solutions. And the solutions have to be in terms of z, because z is the last entry. And I know that's kind of difficult, but we can do this. We can do this. This is unique, and I just lost my way for a moment. This is a solution, but we're not done yet. So we're going to drop this identity in place of y to figure out what x is in terms of z. Okay, so here we go. So in substituting, I'm going to place that into that information. So let's see what we can do there. And I'm going to do it in, say, the first one. All right, so here we go. So I have 2x. Now we're going to substitute. Because we know we're going to have many solutions. 2x plus 5y minus z equals 2. And for this guy right here, we're going to use that. Here we go. A little more involved. I'm going to do distributive property. I'm going to combine like terms. So I'm going to subtract the 4. I'm going to subtract the z, the 4 z's. I'm going to divide by 2. And when I do, oh, that's a 2z. I know you see it. So I'm going to have for the x, I'm going to have 2z minus 1. I'm going to verify. Oh, I made a mistake right there. Didn't catch me. Distributive property is going to be my nemesis on this today. So that's a 20. So this is going to be a negative 18. I apologize for that. Sorry. All right. So I've got it. So got that done. So this is my x. All right. So now what we have is this following as a solution. We're going to have to figure out what z can be, next. So our solution, because we need z as independent, is negative 2z minus 9, z plus 4, and z. Now, we have to determine what z can be. Now, we know in this case that they are, it has to be a dependent variable, and x and y referred to in terms of the z. So how do we solve this, right? Well, we know that if we had the y, hold on, we have y over here, and we solved for it being greater than 0, because y has to be greater than 0, then z has to be greater than negative 4. And then if we state that z plus 4 is greater than 0 for x, then z has to be greater than negative 4. And we know then that x has to be greater than 4. Greater than or equal to negative 4. Oh, I got the wrong one for x. Sorry about that. I did them both for the same one. I apologize. Let's do that again. This is x. So I'm going to add 9. I'm going to divide by negative 2. That flips it. So we know that x has to be less than and y has to be greater than negative 4. So our interval is negative 4 to 4.5. Oh, negative 4.5. And that's where it can live to be a solution for a dependent system. That was involved, wasn't it? It sure was. Well, let's do another one, and that way I can have more clarity in my math. I was carried away. I forgot about z being the variable that it refers to on a dependent system of two lines, because there's two. We cannot do duplication of information. So here we go. On this guy, this time we have a negative here and a positive, and this one's all positive, and it's 15 and 2. So I'm going, and this is a 2, so we're going to get rid of the y's in this case. I'm going to multiply this by 3 and this by 2, because those are in that fashion. So I'm going to have 3x plus 6y plus 15z equal to 45. A lot of math. 4x minus 6y plus 6z equals 2. I'm going to add vertically. Got rid of this. 7x plus 21z's equal 49. That's going to work out nicely, isn't it? I'm going to solve for x. 7x equals negative 21z plus the 49. I'm going to divide by 7, negative 3z plus 7. Does everybody believe that? All right. So this is the dependent system for x. So now we're going to use that to figure out y. All right. So for the y, we're going to do the negative. We're going to do negative 2 plus r1. So I'm going to say negative 2 parenthesis x plus 2y plus 5z equal 15. And the next one is what it is by, because it's a 2x. And that's a minus 3y. Okay, and I'm going to do the distributive property. 2x, a negative 2y, a negative 4y, a negative 10z equals a negative 30. I'm going to do the positive 2x, the minus 3y, plus the 3z equal to positive 2. So here I go. This zeroes out. So now I'm going to have a negative 7y minus 7z equal to a negative 28. Going to work nicely. 7y equals a 7z minus 28. I'm going to divide by negative 7 equals a negative z plus 28. Let's see what I did. See. Oh, that's a 4. Sorry about that. I knew something looked different. 4. So that's going to be a positive 4. So now I have the y. So my dependent system, because I have two linear equations with three variables, the solution. X was And I can put it like this, 7 minus 3z, so I don't have a negative starting, 4 minus z and z. And that's because I have 3 variables and 2 lines. And I did that correctly. Thank you. All right. So now I have this one. Oh, now this one's unique because we have 3 variables, but one of them only has 2, but it does have a z. Oh, now I have to tell you the solution for these. Sorry, I have not done with that one. I apologize. So x equals 7 minus 3z. So x has to be greater than or equal to 0. So we have 7 minus 3z greater than or equal to 0, negative 3z greater than or equal to negative 7. And then when we do the math on a negative divided by a negative, I'm going to have z is less than or equal to 7/3. And then on the y, I have y is greater than or equal to 0. So I'm going to place what it is, negative z plus 4 is greater than or equal to 0. So I'm going to have z is negative z is greater than or equal to negative 4. Now I'm going to have z is less than or equal to a positive 4. So this is our concern here, that it is all values less than 7/3 because z is less than 4. Since z is less than 4, then it also includes the 2 and a third, but is got to be this one because that one has all of the information that's shared by both. All right, so now we have this guy. We have a missing variable, so we have to get rid of the y first. Okay, and this one's a little more tricky because we're substituting once we get what x is. So in this case, I'm going to do 3 times row 1 minus row 2. Okay, because 2 times row 2. So I can have a negative 6 y's. So if I do 3, I'm going to have 3x plus 6y plus 9z equal to 240. All right, now on this one, it's minus 2. So I'm going to have a minus 6y minus 12z's equal to a negative, and that's 48. Right, this guy will zero out, so I'm good. 3x, and I'm going to have minus 3z, and this is going to be a 2, a 9, a 192. All right, so I'm going to, oh, that's not a 12, that's a 8. It's not by 3. That's going to be a z. Sorry about that bad math. So I'm going to have 3x equals to 192 minus the z. And we're just solving for what we have here, right? So let's see, what do I do next? Do I divide by 3 and get a third? And so we're going to divide by 3. Uh, 64. 64 minus z thirds. All right, so now we're going to substitute because um, we don't have a y that we can do. So in this case, we're going to put in the z, that's a z, in and work it that way, and just deal with the fact that uh, we can do the math on it. Okay, so I've substituted that, and now I'm going to combine like terms. Now this is a mess, isn't it? So I need threes on that. So first, let me subtract the 64. Get it out of the way. All right. Okay. So now I'm going to add those guys. So I have a negative z thirds plus, and this is in threes, 9z thirds plus 2y equal 16. So that's going to give me 8 thirds z plus 2y equals 16. All right. So now what I'm going to do is divide. Well, actually, I'm going to subtract uh, to get the y's by itself. All right, so here I go. I'm going to say 2y equals 16 minus 8 thirds z. Okay, and so now I'm going to have, I'm going to multiply by 1/2. Right? So that I have y equals a half of 16 is 8 minus, and this will go in there 4 times, 4 thirds z. And now I have both of them. This was nasty, right? So now I have, for my unique solution, no, my dependent solution, I apologize for that again. I have, for my x, 64 minus z thirds. For my y, I have 8 minus 4 thirds z. And of course, I have my z. Well, now I need my parameters. So we can tell how many solutions there are. In this case, I'm going to solve first for the x. Because this is how many solutions. We can't have negative solutions. I'm going to multiply by negative 3. It's less than or equal to. Um, what am I going to have here? I'm going to have a positive 12, 192 is z. All right. And so it is less than 192. So then we have, for the y, greater than or equal to 0. That's a bunch of answers possible. We have 8 minus 4z over 3 greater than or equal to 0 because we're finding solution number. Negative 4 thirds z is greater than or equal to -8. I'm going to multiply by 3/4. That'll give me a -8 times a -3/4. Well, the 4 divides the 8 twice, and it's going to be a +6. So Z has 7 solutions between 0 and 6. It's 7 solutions. All right. Okay, I'm going to have to do 3 of them on this one. I'm going to stop right here. There was a lot of information on this guy. All right. I wasn't clear at the beginning, and I'm sorry about that. When 3 variables are in a linear equation, then Z becomes independent variable. In other words, the ones that we change. I messed up on the first one and then caught myself. I said, what am I doing here? And so we know it's going to be some kind of expression, and then the Z. Okay, so we know Z is the one we're going to identify with. All right, so then we solve the remaining variables in terms of Z. Then, it wasn't explicit, I just did the math and forgot to tell you reasoning, and that's awful on my part. Then you solve the variables x greater than 0 and y greater than or equal to 0 to find parameter of solutions. As in the last one, ask for number of solutions. And that was from 0 to 6 inclusive. So there are 7 solutions. So much. So we're finished with the second part, and I'll complete this in just a minute for the 2 word problems to help you know the application of. All right. Thank you for listening.